HVAC Fundamentals. What is an air conditioner? An air conditioner is like a goods transporter, but instead of goods, it shifts heat from inside a closed room to the outside of this room, where no one has any objection. To explain this, take the case of a simple split air conditioner. The heat from inside a room is absorbed by the IDU, and discarded outside this room, by the ODU. Principle of cooling. Whenever the pressure of a high-pressure gas is suddenly reduced, it results in cooling. The gases used are called refrigerants. So, the basic steps are: 1. Create a high pressure on a refrigerant. 2. Suddenly reduce that high pressure. Now, if the process is repeated over and over again, it results in air conditioning. The basic vapor compression refrigeration cycle. When the compressor starts, the refrigerant is compressed. This refrigerant leaves the compressor as high pressure, high temperature gas. Now, this refrigerant is cooled in the condenser. It leaves the condenser as high pressure warm liquid. The expansion device, which in this case is a capillary, drops the pressure of this refrigerant. It leaves the capillary as low pressure, low temperature liquid. After evaporation in the evaporator, the refrigerant enters the compressor as low pressure, low temperature vapor. Finally, this process repeats itself, till the compressor stops. This is the animation showing the pre-filters and refilters. Typical installation of filters in an air conditioning system. Dry bulb temperature lines. These are vertical lines. Assume the dBT as 105 degree Fahrenheit. Locate the 105 degree Fahrenheit on the dry bulb temperature scale. Plot the vertical 105 degree Fahrenheit dBT line as shown below. Red line. Wet bulb temperature lines. Locate the text wet bulb temperature. This is a slanting line. All lines parallel to this are WBT lines. Assume the WBT as 75 degree Fahrenheit. Locate 75 degree Fahrenheit on the saturation curve. Plot the WBT line as shown below. Blue line. Relative humidity lines. Locate the text relative humidity. This is a curve. All curves aligned to this are RH curves. The unit is a percentage. Assume RH as 50%. Locate 50%. RH curve. Plot the RH curve as shown below. Yellow line. 6. Take the selected ADP from heat load calculations and mark the point. Components of a window AC. Parts installed on the chassis. 1. Chassis. 2. Compressor. 3. Condenser. 4. Cooling coil. 5. Blower motor. Condenser fan and blower wheel with scroll. 6. Control PCB and dual capacitor. 7. Main electrical cable. 8. Display PCB harness. 9. Swing motor. 10. Vertical louvers and link. 11. Discharge line. 12. Liquid line with strainer and capillary. 13. Suction line. 14. Air sensor placed in front of the cooling coil. 15. Coil sensor attached to the cooling coil outlet. Parts installed on the front cover. 1. Display PCB. 2. Horizontal louvers. 3. Air filter. Miscellaneous parts. 1. Remote. 2. 2-number AAA battery. AHU. This is the animation of an AHU. The return air from the room is sucked through the filter and the cooling coil. Then the cooled supply air is delivered from the top. Induced draft cooling tower. In this cooling tower, hot water coming from the condenser is sprinkled downwards from the top. The ambient air is sucked upwards by a fan placed at the top. The air enters through the mesh at the bottom. It travels upwards through the fills, thereby cooling the water. The hot air finally exits from the top. The cold water collects in the bottom sump. Working of a TEV or TXV. The animation below shows the working of a TEV with external equalizer. In the original position, valve is closed shown with blue arrow. In the pressure condition, the valve is open shown in red arrow. Compressors. Working of a reciprocating compressor. Basically, in any compressor, the pressure of the refrigerant is increased by reducing the volume. In a reciprocating compressor, the pressure of the refrigerant is raised by the reciprocating motion of a piston in a cylinder. The animation shown is that of a typical hermetically sealed reciprocating compressor. It also shows the thermodynamic state of the refrigerant before and after compression. In this type of a compressor there is a phenomena called the pocket clearance. The upward stroke of the piston is not allowed to complete 100% of the cylinder length. This is done to permit some space for the opening of the suction valve. Note that the suction valve opens inwards into the cylinder. Note the following. 1. Blue color denotes cold suction refrigerant. 2. Red color denotes hot discharge refrigerant. 3. Rose color denotes mixture of hot trapped refrigerant and incoming cold suction refrigerant above the piston. What is voltage? Voltage is the pressure that pushes the electrons to flow in a conductor. The unit is volt and is denoted by capital V. Our planet is in danger because of global warming. Global warming. This takes place because of the greenhouse effect, as shown in the animation below. Ozone depletion. The animation below shows the hole in the ozone layer. The harmful UV rays enter the planet through this hole. UV radiation kills. Scholenberg Global Universitas presents a webinar on Electrical Essentials for HVAC Engineers. Main switch. Condenser water pump. Cooling tower. Compressor. Chilled water pump. Scholenberg Global Universitas. Thanks all the 49 participants, for their active participation in our class, on condenser water pipe design held on, April 9, 2022. Thank you for your time. This was a presentation brought to you by Scholenberg Global Universitas. We are ISO 9001-2015 certified private limited company. We have been awarded twice by Niti Aayog as India's top 75 business idea. We are in Thane, Mumbai, and have presence in USA and UAE. Our online courses are available at https://sbgblv.com. Please go to our 100+ testimonials at testimonials.sbgblv.com.